Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, solving basic one-variable quadratic equations. Classwork Example 1. A physics teacher put a ball at the top of a ramp and let it roll down toward the floor. The class determined that the height of the ball could be represented by the equation h equals negative 16t squared plus 4. Where the height h is measured in feet from the ground and time t is measured in seconds. So it would be feet per second. A, what do you notice about the structure of the quadratic expression in this problem? Well, before we continue, I'm going to, actually they're saying expression and it's actually an equation. Since we have h equals, an equal sign, therefore it is not an expression, it's an equation. So what do you notice about the structure of the quadratic equation in the problem? Okay, well here's the quadratic equation standard form. Y equals ax squared plus bx plus c. So in this case, y is h, a is negative 16, x is t time, and that's squared, plus bx, okay, nothing there, plus c, 4. So the constant's 4. So here is the names of all the terms. These are the names of all the terms. The quadratic term, linear term, and the constant term. So you may notice that there is no linear term. And in the equation it says to explain what 4 represents. 4 is the constant term c, but what does it represent in this case? Well, if we were to draw an axis here, okay, so real quickly, so if this were my axis and this is x, and this is my y, okay, this point right here is 0, 0. But this point up here is my constant 4, so it's over 0, up 4. So that is my starting point. So what that means is we are at 4 feet where height is h. Well, we're at 4 feet because if time is 0, if I plugged in a 0 here, 0 squared is 0. 0 times negative 16 is 0. 0 plus 4 is 4. So when times 0, the height is 4 feet. Okay? So the 4 represents the height of our initial position of our ball. Part C says, explain how you would use the equation to determine the time it takes the ball to reach the floor. Okay, the ball reaches the ground when the height is 0. Right? So when does the ball reach the ground? So let me just do this. Here's our ball. All right, so as the ball rolls down the floor or down the ramp, when it hits right here, we're on the floor. So explain how you would use the equation to determine the time it would take for the ball to reach the floor. Well, we would let h equals 0. Okay, height 0. How long does it take for it to get to 0? Okay. Okay, example 2. Lord Byron is designing a set of square garden plots so some peasant families in his kingdom can grow vegetables. The minimum size for a plot recommended for vegetable gardening is at least 2 meters on each side. Lord Byron has enough space around the castle to make bigger plots. He decides that each side should be the minimum 2 meters plus an additional x meters. A, what expression can represent the area of one individual garden based on the undecided additional length? Okay, so it says explain how you would use the equation to determine the time it takes the ball to reach the floor. Well, you would set it equal to 0, so let's do that. So whenever we're doing a math problem, we always write the formula. So we are given h equals negative 16t squared plus 4. So we want h to be 0, so I'm going to say 0 equals negative 16 t squared plus 4. And what is our unknown? Well, our unknown is the t. So I want to get t by itself. So we do the inverse operations of the order of operations, PEMDAS in reverse, which I call SADMAP. Okay, PEMDAS in reverse. To cross an equal sign, you do the inverse operations. So we'd start with subtraction first. There is none. We would start with, then we go to addition. There's addition, so we do the inverse operation of addition. And that will get us negative 4 equals negative 16t squared. So this is a constant or a coefficient times a variable, so that is multiplication. The inverse of multiplication is division. So let me rewrite this. I ran out of room. So we have negative 4 equals negative 16t squared. So I'm going to divide by negative 16. Divide by negative 16. A negative divided by a negative is positive, and this reduces to 1/4. These cancel, and we're left with t squared. The inverse of squaring is the square root, so this kind of doesn't apply because it doesn't say anything about, oh, it does, exponent. So we have an exponent, so we're going to take the square root. So we take the square root of both sides, and I'm going to revisit the rules of square roots. And when you have a fraction under a square root, you can make the numerator in its own radical, and you can put the denominator in its own radical. And the square root of t squared, they are inverse operations. They cancel each other out. We're left with t. And the square root of 1 is 1, and the square root of 4 is 2. But remember, when you take square roots, they can be positive or negative. Okay, so now consider the two solutions. So we have t equals 1/2 or t equals negative 1/2. Which one is reasonable? Remember, that's time. And obviously the negative 1/2 does not make sense because there's no such thing as negative time. We can't turn back time. So our answer is positive 1/2. And that is, always have to be careful, measured in seconds. So this is, it would take a half a second for the ball to roll down and end up here. Okay. Example 2. Lord Byron is designing a set of square garden plots. So I'm just going to draw a square here just so we remember. Square garden plots. I mean, let me do it right. Okay, square garden plots. So some peasant families in this kingdom can grow vegetables. The minimum size for a plot recommended for vegetable garden is at least 2 meters on each side. So if this is at least 2 meters by 2 meters, Lord Byron has enough space around the castle to make bigger plots. He decides that each side should be the minimum of 2 meters plus an additional x meters. So we're going to add an unknown, x plus 2, and this is going to be x plus 2. So this is x plus 2 meters by x plus 2 meters. And let me put those in parentheses so we don't think that m is a variable. X plus 2 meters and x plus 2 meters. Okay, so what expression can represent the area of one individual garden based on the undecided additional length x? So remember, I always write a formula first. Area equals length times, well, let me use side squared since it is a square. It is length times width, but since the length is equal to the width, we can call them sides, and area equals side squared. Substitute in the givens. Our side length is x plus 2 squared. So there is the expression. What expression can be represented? So since it's an expression, we don't want an equal sign. Okay, there it is, x plus 2 squared. There are 12 families in the kingdom who are interested in growing vegetables in the gardens. What equation? Equation, so there's going to be an equal sign. Can represent the total area A. So area A equals 12 people times the number of squares, and then area of the squares is x plus 2 squared. Okay, so there's our equation. Area equals 12 times x plus 2 squared. If the total area available for the garden is 300 square meters, what are the dimensions of each garden? Okay, so now they have given us a given. The area, total area. So the area, that's my A, is going to get replaced by 300 square meters. I'm going to write this as meters squared equals 12 x plus 2 squared. Okay, and now we need to solve this. So, first thing we want to do is get rid of this 12 right here. We're trying to solve for x. Always ask yourself, what is the goal here? We want to get to find the value for x. So I'm going to divide both sides by 12. Hey Siri, what's 300 divided by 12?
300 divided by 12 is 25.
So we have 25 equals the quantity x plus 2 squared. Now in order to solve this, we now have a square, so we take the square root. And the square root of 25 is plus or minus 5, but we're talking about side length, so let's just ignore the negative. We can't have a length negative. So the square root of 25 is 5, and the square root of x plus 2 squared is simply x plus 2. Square roots and squares cancel each other out. Okay, so now we're down to just subtraction. Subtract 2 from both sides, and we get x to equal 3. Okay, so he needs to add 3 meters to the given 2, so it's going to be 5 meters. D says to find both values for x. That makes the equation in part C true. The solution set, what value of x does Lord Byron need to add to the 2 meters? He needs to add 3 meters. Okay, so it did say to find both values, so I should go back and fix this, and it's plus minus, plus minus. So now it says to find both, so let me just erase this step here. I got ahead of myself here. So now I want to set up 2 equations. 5 equals x plus 2, or negative 5 equals x plus 2. And I subtract 2, and I get 3 to be x. And I add, subtract 2 here, and negative 7 equals x. Okay, so there are my 2 solutions. And obviously, we can't have a negative distance, so the answer is 3. Exercise. Solve each equation. Some of them may have radicals in their solutions. Okay, so this is just solving equations, and I'm going to write this up here each time. I did this in 7th and 8th grade, but I'm going to keep doing it just to remind you. Some still struggle with solving equations. It's PEMDAS inverse. And anytime we cross an equal sign, we do the inverse operation and we do the orders backwards. So I write SADMET. So is there any subtraction? Yup. And the inverse of subtraction is addition. So I add 9 to both sides. And I'm left with 3x squared. Negative 9 plus 9 cancels or equals 0. And 0 plus 9 is 9. Now I don't have any addition. I don't have any division. I have multiplication. The inverse of multiplication is division, so I'm going to divide by 3. The 3's cancel. 3 divided by 3 is 1. 1x squared equals 9 divided by 3, which is 3. And now I have an exponent, and the inverse of squaring is square root, so I take the square root of both sides. So x equals positive or negative square root 3. Radicals in their solutions. Okay? Number 2. I'm going to redo this SADMET here. Okay, I decided to make this a little bit neater, so here we go. Number 2. All right, so we look at this here. We have parentheses. So here parentheses, it says our last. So there's nothing outside the parentheses, so that does not apply. Just keep that in mind. Okay, there's nothing outside the parentheses, so we're going to work in the parentheses. And the first thing we look at, so we work our way in. So sometimes SADMAP isn't the proper order. The squared is outside, so we're dealing with the exponent first here, and so the inverse is the square root. So what I'm going to do is take the square root of x plus 3 quantity squared and take the square root of 1. And when I take the square root of this, the squared and the square root cancel, and I'm just left with, and I don't need the parentheses anymore, I want x. So I write it again, okay. X plus 3 is going to be left over, equals positive or negative 1. So whenever we have that, I'm going to write that differently. I'm just going to write x plus 3 equals 1, or always write or in between because it can't be the same, it can't be and, or x plus 3 equals negative 1. And now I'm at subtract. I have subtraction, so I'm going to do the inverse of subtraction, which is addition. No, I don't have subtraction. I have addition. I'm going to do the inverse, which is subtraction. Minus 3, minus 3. So I'm going to subtract 3 on both sides in each equation. These cancel, and I get x equals 1 minus 3, which is negative 2. And I'm going to subtract 3 here, and I'm going to get x equals negative 4. So the answer is x equals negative 2 or x equals negative 4. Okay, number 3. Okay, we're always going to work from the outside in. Okay, so I have this 4 here. I want to get rid of that first. So that's multiplication, and the inverse is division. So I'm going to divide both sides by 4. Get the parentheses by itself. These 4's will cancel, and I'm left with x minus 3 squared equals 1/4. Okay, now I have exponent, that's right here, and the inverse is the square root. So I will take the square root of both sides, and this will leave me with x minus 3 equals, the square root of 1/4 is 1/2, and it's positive 1/2 or negative 1/2. So I am going to just write 1/2, or x minus 3 equals negative 1/2. Okay, I'm going to add 3 to both sides in each equation. Okay, and when I do that, these cancel, and I get x equals 1/2 plus 3 is 3 and 1/2, or x equals, these cancel, 1/2, negative 1/2 plus 3 is 2 and 1/2. So my answer is 3 and 1/2 or 2 and 1/2. Okay, now going back, I'm looking at my work here. I went from minus to plus right here. That's a negative, so this would be a negative. This would be plus. This would be plus because that's a negative, and my answers are positive 2 or positive 4. Okay, sorry about that. Okay, now let's move on to number 4. And let me get this out of the way. Okay, here we go. Clean slate. All right, so choose purple this time. I have 2 times a quantity that is squared. I want to do everything outside the parentheses first, which is the 2. 2 parentheses means multiplication right here, and the inverse of multiplication is division, so we divide by 2 both sides. The 2's then cancel, and we're left with x minus 3 squared equals 12 divided by 2. Okay, now we have an exponent. Exponent is, this inverse is the square root, so I will take the square root of the left, I will take the square root of the right. That will leave me with x minus 3, I don't need the parentheses anymore, equals 6, or x minus 3 equals negative 6. Now I have subtraction, and I'm going to add. Add 3 to both sides here. 3's cancel, and I'm left with x equals 9, or I add 3 here and here, and these cancel, and x equals negative 3. So the answer is 9 or negative 3. Okay, I made another mistake. Square root of 6 is not 6. That's still a square root symbol here. That's still a square root symbol here. So I don't have 9 and I don't have negative 3. All right, so let me fix this. It will be 3 plus the square root of 6, or 3 minus the square root of 6. It did not say to put it in decimal form, so I'll just leave it like that. You could put that in your calculator and estimate, but I will leave that in radical form. Number 5. Okay, number 5 says to analyze the solutions for exercises 2 through 4. It says to notice how the equations all had the quantity x minus 3 squared as a factor, but each solution was different: radical, mixed number, and whole number. Explain how the structure of each expression affected the problem solution pair. So if I go back to the last page and I look at these, this had a 3x squared minus 9. Well, that came out to be a perfect square. So what happens when we have perfect squares? What happens when we have perfect squares? Where is it? Right here. Oh, they want us to look at number 2, 3, and 4. Parentheses, x minus 3 squared, x minus 3 squared, x minus 3 squared, not number 1. 2 through 4. So when we add this, 1 is a perfect square. And when we have a perfect square, we get integer solutions. Okay? And number 3, we had a fraction. And the fraction is a perfect square, so we're going to get a fraction solution. The solution to this was 3.5 and let's see, no, it was 7 halves or 5 halves. So that is 3 1/2 and 2 1/2. I erased it. So we had a mixed solution. So whenever our fraction is a perfect square, then we're going to get fraction solutions. And when we divided by 2 here, the 12 divided by 2 is 6. Well, that 6 is not a perfect square. So 1 is a perfect square, integer solutions. 1/4, each numerator and denominator are perfect squares, and we got fraction solutions that were not radicals. And then here, 12 divided by 2 is not a perfect square, so our solutions were in the radical form. So that is number 5 explained. Number 6, Peter is a painter, and he wonders if he would have time to catch a paint bucket dropped from his ladder before it hits the ground. He drops a bucket from the top of his 9-foot ladder. The height h of the bucket during its fall can be represented by the equation h equals negative 16t squared plus 9, where the height is measured in feet from the ground. Okay, before I go any further, notice that whenever we're talking about gravity, the quadratic portion is negative 16t squared. That's the speed of gravity. That's the pull of gravity. The constant at the end is your starting point. Okay, so it says where the height measured in feet from the ground and time since the bucket was dropped. So h is height in feet, t is time in seconds. After how many seconds does the bucket hit the ground? Do you think he could catch the bucket before it hits the ground? Okay, so I drew a diagram here. So the bucket would be right here, okay, and it's going to fall. All right, so it says the height of the bucket during its fall can be represented by this equation, where the height is measured in feet and the time in the bucket was dropped, t, measured in seconds. After how many seconds does the bucket hit the ground? Okay, so the height is our initial starting point, our constant. So h equals 9. So this is 9 feet. So x is time. So this isn't really the right diagram for this, but it's time. How long does it take the bucket to fall from here to here? Okay, anyhow, that diagram really doesn't work so well, but it gives you a picture as to what's happening. So what we want to do is solve for a value. So h equals negative 16t squared plus 9. I always copy the original. And in this case, we want it equal to 0. We want to know how long it takes for it to hit the ground. So h is going to be 0. The height is going to be 0. So how long will it take to go from 9 to 0? So the height 0 equals negative 16t squared plus 9. So in other words, I want to get t by itself, so I subtract 9 from both sides. And I get negative 9 equals negative 16t squared. I'm still trying to get t by itself, so I'm going to get rid of that 16 by dividing by 16. And it is negative. So negative divided by negative is positive. And I get 9/16 equals t squared. So to find t, I have to take the square root of both sides. So the square root of t squared is t. And the square root of 9/16 is plus or minus 3 square root of 9 over the square root of 16, which is 4. So the answer is plus or minus 3/4. Well, time can't be negative, so I'm just going to erase the negative sign because we're only worried about our positive solution. So the answer is 3/4 of a second. So the bucket will hit the ground after 3/4 of a second. So I don't think he could catch the bucket before it hits the ground. It would be impossible for him to descend the 9-foot ladder, catch the bucket in 3/4 of a second. Okay, that is the end of lesson 6. Review the lesson summary and go to your problem set.